How's everybody doing today? Good morning. For those people on the East Coast where it's 11:30, we're just getting started. It's 8:30 in the morning. I'm already practicing my passive solar strategies. This is called the redneck passive solar strategy, shading, right? Comes in handy when you go fishing and hunting like I do. So, my name is David Butts. I am the BIM specialist for Gannett Fleming Engineers based out of Harrisburg, Pennsylvania. But I work out of my house out of Fuquay-Varina, North Carolina. Anybody know where that is? Show of hands. Anybody know where North Carolina is? That's good. That's good. So, little thing about our class today on capitalizing BIM for energy modeling here. I've got 30 years experience with Autodesk with their software products. Got my associates in architectural technology from a million years ago. Got 13 years experience in the reseller channel and was a senior application engineer and a technical training manager. I've been with Gannett Fleming now for 6 years, and I manage all of the engineering software packages that we use. I'm certified in both Revit MEP and Revit Architecture, but I also am part of the Autodesk Expert Elite program. Anybody know what that is? We actually provide 30% of all the tech support that is done by Autodesk through the forums and through questions and things like that. So there may be some times where you'll get something that comes up from an Expert Elite member. So if you get a chance to talk to us, say hi. So what we're going to be talking about today is how to get and prepare and capitalize your Revit model for energy modeling, right? So we're going to review what the energy model needs from Revit and then discover how to create that energy model and review the results. And then learn what the predicted analysis is going to be here and the energy cost. And we're going to take a look at 360 today a little bit. We're not doing a live version of the software. We're just going to look at some notes about this. So yeah, we're going to do death by PowerPoint this morning. I'm really sorry. But we're going to take a look and talk about all these things today. And so our key learning objectives, here they are again. Mainly, how do we set Revit project up? How do we get the workflow nailed down? And then how do we do an energy model in Revit? What are the key things that we need to do before we do the model? Then we're going to look at Insight 360. Show of hands, how many people have actually looked at Insight 360? Okay, how many people actually use Insight 360? Handful, so it's still pretty new. We're going to take a look at that today. So, why? These are the reasons why somebody would consider using Revit as an energy model. It's to gain a better understanding of design impact on the environment and on resources, natural resources that we have, as well as leveraging our design models from construction documentation, and then being able to communicate ROI on different strategies while minimizing design cost. Man, that's a lot, isn't it? I'm going to diverge a little bit because guys know I can't do this. You probably know that I'm a little conservative. I hunt, I fish. Anybody who knows me for a long time knows that I love being outside. So I'm probably the last person you would expect to talk to you about climate change and about energy and resources. Why? If you listen to the news and you listen to the media, all you're going to hear is negative things about somebody like me. But I have a different interest in it. I'm from a different school, a different time. I grew up in the woods. I grew up outside. I love being in the outdoors, and it's critical to me that my grandchildren have the opportunity to enjoy the same things that I did. So how we manage our resources is extremely important to me. And you hear a lot of narrative about climate change, and a lot of times it's kind of pitting everybody against each other, and that's kind of not the approach we need to have. We need to change the narrative. We really do. It doesn't need we need to change the narrative from people who want to divide us on the topic to allowing us to come together at a common goal. Does that make sense? And climate change can occur in a vast variety of ways. I mean, think about it. We're a big rock spinning through space at 260,000 miles an hour. And at some point, we're going to get an asteroid in our lane, the fast lane, little blue-haired, white-knuckle old lady doing 35 with the left turn signal on, right? You could have somebody up like that in the fast lane and get out of the way. I'm going fast. There's so many things that could happen, and what scares people is we really don't know. We don't know what's going to happen. We have a pretty good idea, and we can run models and simulations to see what that impact is. But until we decide that we're going to address this, then it's going to continue to be a problem. And the biggest mistake we did was hand this topic to the least qualified people possible. Politicians, right? Those are the people that you absolutely don't want to hand the keys to the car to. And so that's why I want to make sure that everybody understands that this class is about us taking that control back and making sure that through the tools that we have, that we can do what we need to on our local level to make sure that we're designing efficient buildings and we're communicating it clearly to our clients. Because, you know, sometimes our clients aren't the most sophisticated people. They deal in images, right? You ever walk into McDonald's, see a cash register, you see a picture of a Big Mac. What do you see now? Everybody and his brother has one of these, right? And so everybody smile for the camera. Awesome. And we are enamored with imagery. And so how does something like Insight 360 help us? It's really about sales. What are we doing? We're selling an idea. We're selling a concept. And that concept means that we're trying to get people to buy into the notion of how we can make your buildings more efficient. Does that make sense? So keep in mind, this is a sales tool. And what we're trying to do with tools like Insight is to help make that presentation clearer for the layman, to somebody who doesn't understand all the spreadsheets and the numbers and the evaluations and the simulations that run, and put it to them in a form that's easy to follow and to help us get buy-in, because you cannot succeed without buy-in. Does that make sense? Okay, cool. That's my political snub for today, and that's probably the last time you'll ever hear that out of me. So, like I said, I love the outdoors. It doesn't matter to me whether it's Folly Beach on an October morning, watching the sun come up, or hiking around Silver Lake in Utah, where I was back in August, and very short of breath. But, you know, these are things that are important to me, and that's why I feel like it's important for us to do this and to take care of this. So let's kind of start off talking about project setup and modeling tips for best analysis results. And so I want to talk to you a little bit before the project setup. These are some decisions that you have to make early on here. And you need to understand first, what type of energy modeling are you going to do, and what are the details that are required? How many people, show of hands, have to deal with federal agencies and deal with federal projects? Is everybody aware about the new energy modeling standards that are coming up that you're going to be required to do? If you're not aware of it, you need to be paying attention. And so you need to know what those requirements are, and you need to make sure that you understand what those federal, state, and local governing agencies require. Well, let's get that out of the way first. There's always going to be that requirement. So we want to make sure we're at least meeting that as a minimum. To me, I want to exceed it. I want to go past it. And the other thing to understand is what's the expected energy use intensity metrics. What are you looking for out of the design? Now, I actually had to stop and ask myself, what the heck does that mean? Energy use intensity, is that how much I pedal, how fast I pedal on the bike in the gym? Which is really slow for me, right? It's really defined as the amount of total energy consumed by a building in 1 year, and it's divided by the total gross area of the building. This is what energy use metrics are. And so when you look at tools like Insight, what you're looking at is what those energy cost means are and what the annual costs are. And we put those down in simple numbers that people can understand. That's what's important about this tool. And so you have to understand the compatibility with what standards we're trying to comply with. You know, DOE 2.2, ASHRAE 90.1, 140, ASHRAE 62.1. These are all guidelines that help us understand what's going on with the building. So before you start, you need to understand are the tools we use compatible with what we're doing. And for example, the heating and cooling load analysis tool is based on Energy Plus now that comes from Insight. So it's important to know that that's what information we have. So when you're setting up the project, how many of you guys use templates to set up your Revit projects? Great. Most of you do. Anybody in here use starter projects? A handful of people. What's a starter project? It's a project that's already defined as a central file with predefined work sets that you save as a new central. Saves a lot of steps. Helps you make sure you get your work sets right. Well, these are some of the steps that people need to take, and it's really funny because usually when you talk to architects, what are they doing? They're turning that area and volume calculation off, right? Because it slows their model down. But if you're going to use the model for energy analysis, you have to turn that on. You also have to understand building and space types, and this is something we're working on to try to make better for everybody, to try to make it an easier tool to use. And so in this case, you can pre-assign building space types that are going to be used to assign for engineering purposes, predefined values for things like what's the area per person and the sensible heat gain, the lighting load density. All of these are factors that come into account when I'm running an energy model. When is it the time to think about this information? It's before I start the job. If you have it set up in your templates, it saves you a great deal of time. Here's something else that just came around a few years ago. Here's material thermal properties. Now, how many of you guys actually look at materials that are assigned to a type? A few of you? That's good. Because it's not just about rendering. It's not about hatch patterns. If you're still in your CAD mentality, you're thinking behind the 8 ball in this case. And so when we look at the material thermal properties have been added so that you can actually see these now. You can actually see what the thermal conductivity is, the specific heat, the density, all this stuff is assigned. So when you do a detailed energy model, this information is used. Why do you put it in the template? It's already assigned. So there's 2 ways to approach this. And again, you want to make this decision before you actually start working on your model. And the first decision you're going to make is whether or not you're going to use conceptual masses and shapes or building elements. And so how many of you guys have ever used a conceptual mass? Handful of you. Not as many, because there's really money in the budget to do this. And I'm more likely to do this, especially when I get into urban areas, because you have a lot of factors that can come into play. So if I'm designing a new building, and that's what this is for, is I'm going to draw a conceptual mass that I'm going to use in early preliminary stages because it's easy to orient to a site and because we can add mass floors for analysis. This is good for overall studies. In other words, I'm not trying to get into the detail. I'm trying to get that big 30,000-foot picture of what's going on with the building and the design. And it can be any type of shape, and that's the beauty of this. Some architects don't create buildings that are boxes. Who'd have thought? Right? Yeah, all you have to do is go down the street to Center City, and you'll see some boxes that don't go straight. So this is a great opportunity for you to take advantage of those conceptual masses. Now, there's the other element is the traditional CAD approach to projects, and this is what's called building element modeling. This is where you use architectural bounding elements, walls, openings, floors, ceilings, roofs, objects that represent the building. But let me ask you something. In 2D CAD, does that stuff always get created? No, it doesn't. Another common mistake that people will make is they have a tendency to start off doing what we call spilling your candy in the lobby. They want to show to the client in preliminary stages of design what looks like a finished model with all these pretty materials and everything else. And if you haven't worked out the concepts of the building to make sure that it's working the way that you need to, you really can over-model sometimes too early. So it really kind of depends on what type of a model you're doing. You know, do I need the materials for the thermal properties? I could get away with just a generic wall in some cases. So you want to model accurately. This is another thing that happens when we get into projects, and I know we're talking about before the project, but I need you to be thinking about this. This is not AutoCAD, okay? People have a hard time with this when it comes to energy modeling because they're not used to doing this. You can't fudge things. You can't change a dimension. You need to model accurately. And one of the biggest mistakes that people make is they don't correctly join walls, join ceilings, host objects. That's the biggest mistake. So you want to make sure that your preliminary model is going to be done accurately. So this is what you do before the job. You make sure you're putting somebody on the job that knows how to use Revit. We don't want somebody who's really breaking things in because they could be making some mistakes. Another common mistake that people will make in their energy model is they try to put too much detail in. They add too many features. They include column enclosures as room bounding elements. They put in bumps, cutouts, reveals. They hang their mom's picture on the wall to make it pretty for the rendering. That actually can screw up your model because the more surfaces that you have, the longer it takes for the energy model to be defined. So you want to make sure that that stuff's not included. So when you get into building element modeling, this is the part that most people miss. They don't pay attention to the vertical aspects of their design. They're not really looking at what's happening up and down. What's wrong with this picture? Somebody tell me what's wrong? Speak loudly. The spaces don't go all the way up the roof. Now, I'll tell you, I did design the room to go up to the roof, but what happened in here? I have a ceiling. And so the ceiling is a bounding object, and it automatically stops the room. So what do I need to do to fix this? I need to go add another room, or in the MEP model, add an analytical space that's considered a plenum. So it doesn't necessarily mean that the architect needs to do it, but the engineer definitely needs to do it if we're doing space-based analysis. So you can't skip those steps. And another step that we don't get enough of is people actually using rooms, spaces, and zones for something other as a mechanism to tag an area. You have to make sure that you're putting these things in correctly, because in the MEP side of things, I'm going to use that space against the room and pull that information from the room, but I'm also going to use spaces in interstitial areas, chases, and everywhere else to help me do a better model. That make sense? Okay, so we're going to talk about energy modeling settings and features. And these are a couple other things that you need to look at after the project starts to make sure that everything's working correctly. The first thing you're going to look at is the project information and energy settings. And these are set after the project is defined, and they can be modified by location. Let's go with another show of hands here. How many people are still on Revit 2016? Has anybody gotten 2017.1 yet? Okay, that's good. There's been some changes to energy modeling. We're going to take a look at those in a few minutes in here. But how many people are on the software release before 2016? Okay, get out. Sorry. You don't have access to Insight if you're on something older than Revit 2016 R2. So you have to do what I call old school. You got to do me. So that didn't sound right at all. What you have to do is you have to use the Green Building Studio tools, which have been around for a long time. Okay? And you still have the same type of inputs, but again, knowing before you start the project that I'm going to be doing an energy model means going in when the model is defined and setting up things like the location and some of the default settings that you have in here. And that's the project energy settings are a subset of the overall project information tool that's found on your Manage tab in Revit. And it's essential for energy modeling. You need to have that. You need to make these adjustments here. So when you're looking at the properties for energy settings, you can see that we use conceptual masses, building elements, or both. Those are the types of analysis that you can do. You also have to know what the ground plane is going to be, what level of the building actually establishes the ground, because underground walls have a different behavior than above ground walls. You also have to know the project phase. How many people are actually planning on doing energy modeling around an existing building? We did a project for WMATA where we were renovating an older building, and we actually had to break that project up into pieces by floor level because we were only phased at one project at a time. So we had to make sure that we told Revit whether it was doing existing or new construction phasing and picked the right category for what it was looking at. So those are things, again, you have to think about. There's even more energy analytical model settings that are essential to these tools in here, and analytical space resolution is one of the big ones. Anybody know what this tool does? Analytical space and analytical surfaces, you have an idea what it does?
It takes, it's the accuracy of the energy modeling. The less it is, the more accurate it is. It's like the resolution of that.
Okay, that's sort of correct, but let me tell you what it is. It's actually looking for gaps in the model. In other words, suppose somebody doesn't completely close a wall, or there's a reason for a wall to have an opening there. That can result in too many surfaces. So when you set the analytical space resolution up to be 1'6", which is an average number, then it looks for those gaps. Now you have analytical surface resolution that's been added in here recently that actually allows us to look at the surfaces themselves and say, where I don't have a completely closed off surface, I want you to go ahead and close this area off. And this kind of helps with things like the reveals, you know, the things that get put on the wall, openings that may be there. It kind of helps figure those out. You also have perimeter, zone depth, and division. Now, this tool comes into play when you're actually doing conceptual massing and you're doing conceptual studies. And what it does is it breaks the building down into zones by looking at an interior and exterior condition. And the perimeter zone depth says, how far inside of this conceptual mass am I considering those to be outside walls? And then beyond that, it considers the rest of the part as interior construction. So when you set up your conceptual construction types, that's what actually tells this thing how to behave in that case and where to look at that information. So there's a few other keys in here for rounding out what you're going to do with your analysis in here. And the new one that I like is the detailed model settings that kind of break things down in more detail than we had in the past. A conceptual construction is basically a setting inside of Revit where you go in and say, all exterior walls are going to be this, all interior walls are going to be this, your windows are going to be this, your exterior windows are going to be this, your doors are going to be this, and they have a predefined U value assigned to those. So it's dealing in generalities. It's not specific. The next level is the building element. But if you go to the detailed model level, what you can actually do is include more detail like the target percentage glazing, the sill height, the shade depth, skylight sizes. That information becomes considered, and the thermal properties also become considered. That's when this actually comes into play. So yeah, you can get a pretty detailed model. It may take a little bit longer to generate, but you can get a more accurate result. So as we look at this, we want to make sure that we're putting in the right building data in here. You want to make sure that you're putting in what the type of building is, the operating schedule, a general idea of the HVAC system. We also want to know what kind of outdoor information we're going to have, how many air changes we're expecting. Again, these are general information for the whole project. And then you also need to know how you're going to be sharing your model. Now, this is important. This is where people miss stuff. They're in an MEP model, and it's set to export spaces, and they don't get a model. Why? Because the linked architectural file has the rooms in the link, not in the current file. That's where the most common GBXML export problem occurs, is because somebody hasn't gone through and made sure that they're picking the right type of export in this case. So you get two options, rooms or spaces. Me personally, I like doing spaces because I'm working in the MEP model, and I'm doing more with spaces that go in areas where you don't have rooms. Make sense? Architecture, generic, Birkenstocks, wool socks. Engineers, Merrills, right? A little more detail. Close it up a little more. And then you decide whether or not you're going to use material thermal properties with your detailed elements by checking that box. So you can actually go in and change your schematic types from being building to being something else. You can actually set up a series of different schematic types now, building constructions. That's pretty cool. All right. What also makes this work is having an internal tool, not having to go outside. How many people are still using Trace? How about virtual environment? Use that one. Anybody using Green Building Studio right now? Wow, not a whole lot of people. See, this is why we need to do this. We got a drop off in actually using these tools. And what helps this become easier and helps us get over that communication and that hump is making sure that we have the tools built in as much as possible in here. So the built-in tools or vendor add-ins are critical to making this work. And if you look up on the screen, you're going to see that I've got two examples in here. We have the Revit 26-2017 Analyze tab that has the Insight 360 plugin already loaded. And we also have the out-of-the-box energy settings, create energy model. Revit 2017.1 introduces a new tool. We're going to talk about this a little bit later called energy optimization. And now it's part of the package. So you need to make sure those tools are built in. And then after reviewing all this information before you go into Insight, the last step you do is click one button that says create the energy model. How difficult is that? It's one step after all of the setup before. And once the energy model is live, it's there. And you can continue to make changes to the model and export the model and send things out. It's based on all the volumetric spaces of the elements. Remember we talked about the EUI metrics earlier? The gross floor area? And those are the things that we're looking at. And before 2017.1, one of the reasons why I didn't get this handout done until about 2 weeks ago was making sure that the tools were included in here now. So 2017 now includes that energy optimization tool. So the steps are really simple. You create the energy model, you let it create the analytical model, and then at that time you can go ahead and run a simulation, and it will go out to Green Building Studio, run the analysis, and then allow you to compare and review results. This is the old school way. Everybody pretty cool on this? Let's step the game up a little bit. 360 is like a catch-all number. We got Insight 360, Fusion 360, BIM 360, Office 360, my dog 360. We got 360 apps. All it means is we're spinning around in circles all day long, right? Insight 360 is something that came out a couple years ago and was offered through the development. Anybody familiar with labs.autodesk.com? Great site if you ever get a chance to go there, beta.autodesk.com. Get in there. Autodesk is saying, hey, come help us out. So they started using that application, and I got in and started presenting about this actually last year at the ABIPSA conference. And I also presented on this at ABIPSA in Salt Lake City this year. And it was really fascinating looking at all the different people and their take on how energy modeling was supposed to take place. And I'm sitting here looking at it going, why can't I just do this in Revit? Why do I have to send things out? How much can I do with my native package and then just get reports generated for me? And then be able to continue to make the changes. So it's a web-based energy modeling tool, still outside, And it's integrated several analysis tools into one interface in here. So when we look at this, it's available for 2016 R2 and integrated with 2017.1. And it shows up as its own panel on the Analyze toolbar. And when you click Insight 360, it's going to take you directly to their web page where you can start to look at some of the reports that you have. And the way this works is actually really simple. An analysis is referred to as an insight. Give me insight. I love that word. Help me understand. Those are the three things that you can say to somebody that really gets them to open up. Help me understand. And so the analysis is referred to as an insight, and it's based on model runs. It looks at several different tools and says, what can we do to be more efficient with this building? And it generates these reports for specific areas where you can make an efficiency gain. Now, Insight is not just generating the reports for you. It also brings in a 3D model, an analytical model, and it has a viewer that allows you to explode this building and look at individual components and see what their properties are. Now, why is it helpful for me to have this in a nice, fast little viewer? Do you have someone in your office who you wouldn't let touch Revit for all the money in the world? Yes. They're called engineers in my office. Some architects, too. I love my engineers. They're great guys, but they're not always really good at Revit, and they have something that they like to do called change things. It's like, no, stay out. Okay? So in this particular case, somebody can actually just go to a web portal. Hey, think about this for a second. We talk about the technology here. Where's a place that I can go view this information? Where can I go look at this? The internet's everywhere. Interweb is everywhere, right? And I can go view this information at any time as long as I have internet access. And so that gives me the opportunity to take a look at what's going on with the model and what's going on with the tool. So after we do this, we have several specific reports. The first report we have is a benchmark, and it shows the overall rating of the building. And as you see in this image up here, the benchmark is set into an area where you're really looking for green, but you don't want to be in red. And it also includes what the area averages are and what targets are for something like ASHRAE 90.1. As you make changes to the components in the model, this benchmark will move up and down, and the energy cost mean will also change. So it's dynamic. It changes as you make changes to your model. You have a model history. I can make several runs, and I can examine individual runs. So as I go back and I start looking at solar and lighting analysis and start saying, okay, what happens if I introduce PV into this? How big of an impact is that going to have on the cost mean? And so you can actually look at different runs, and you see that little bar on the bottom that goes across. It looks like it's getting skinny. I like the skinny one. I don't like the big one. That means we're burning up a lot of energy. Then other things come into play like building orientation. How many of you guys, by show of hands, do site-oriented projects? Not too many. Why not? Because you use the CAD mentality of 0, 0, right? Does everybody start their buildings from like a lower left corner of a building? Again, we do a lot of water and wastewater and transportation. We do dams in Revit. We have some really cool guys that model for us. And one of the things that they've learned how to do is how important it is to geolocate a project and make sure that you're putting something in at the correct coordinates on the site. Well, when you're actually siting the building in the early stages of design, you're seeing all this stuff. You're seeing the impact of the solar studies and the shadow studies. You're seeing the impact of the building on the site. You can see things like where solar gain is going to come into play. And so you need to know what the building orientation is and how that can affect the energy model. You also need to know what something like the wall rating is going to be. What happens when I introduce a conceptual wall that's just basically a concrete mass, and then I come back later and I replace it with a brick and block wall? What is that going to do? So it actually shows you what the current setting is and how it's affected by daylighting and heating and cooling. When you get into window shading, you can actually say, I want to have this type of a window shading included, and it doesn't even have to be modeled. This is just a setting that makes a certain assumption for you that says, I'm going to allow for 2 feet of shade on all my south-facing walls. And I can break it down by different orientations of the building. We also have window glass. It was really funny. I was talking to somebody that, I can't remember the city, but they did an all-glass building, and the problem was that the E value was so high, the reflectivity was really high, and it was melting all the walls on the building adjacent to it. Okay, we got a little carried away on that one. Should have done a solar study before, right? We could have actually seen that. Hey, you've actually seen that in residential neighborhoods where that vinyl siding just drips. It goes right down. I thought about doing that to a neighbor I didn't like. You also can look at wall construction. This is where those conceptual types come into play. You know, what are the materials of the wall? What's the U value, the R value of the wall? How does that come into account? And by looking at different conceptual types, can I include that? Looking at the roof construction. You know, make sure you're putting a roof in the building. You know, if you're going to do building element design, make sure you have a roof there. Otherwise, it's really ain't going to work. Otherwise, you're back to conceptual types, and without the roof there, it has to have that for area so that it knows how big the roof is going to be. Infiltration is key in here. Well, this is a general project setting that says how tight the building is going to be, and it used to be addressed by 3 values: tight, loose, and messy. And well, actually, one more. I think it was, what was it? Tight, loose, and messy, and something else. There's like 3 or 4 of them, and they actually had that in Revit. It's really kind of cool. Lighting efficiency. How efficient are my lights going to be? Now, this relates to heat gain, not necessarily to lighting levels in a room. It relates to heat gain and the impact on the space itself. So if I have a lot more lights, I got these Klieg lights I have up here, which are giving me a sunburn. You know, they can actually cause a bigger heat gain in a room. So I might want to look at something that has a better efficiency, like an LED light or something that doesn't put out as much heat. Daylighting and occupancy controls. Are we doing occupancy sensors? Are these part of the design? And again, that's a setting for the overall project, as well as something like plug load efficiency. What is going to be the impact on the heating and cooling of a building by the amount of equipment the vendor or the owner has inside of that building? So you can actually preset what those plug loads are going to be. Then we get into the fun part, HVAC. Who's a mechanical engineer in here? Do you guys know what HVAC system you're going to use when you get started? How often? If you say yes, I have therapy for you. I love my engineers. They have a tendency to think too hard about some of this stuff. And what we need to be looking at is general pictures. We need to be looking at things that say, okay, how long do I need to have these systems run? How efficient are they going to be? Am I going to be using something like a variable refrigerant flow? You know, what are the new technologies that I can use? The operating schedule becomes important. If you assume that a building is going to be open 24/7, are you really going to get an accurate read on what the building energy costs are going to be? No. My house is not a 24/7 occupancy. Well, the dogs are there all the time, but that doesn't really count. But if you think about it, when you look at something like a school, you might have a 12/6 type occupancy that you deal with. And believe it or not, that does make a big impact on your EUI metrics. So you want to make sure that you're taking care of this. Then we get into photovoltaics or PV. We took a look at things like payback limit. What are our options here? You know, how long is that stuff going to take? And these are all options that you have. By the way, the presentation is going to be available. And you have great handouts, like 60 pages long. It goes into great detail about these. So when you're discovering Insight 360, what you're going to do is look at these different reports. Every one of those tiles you saw shows up in the Insight web portal. And when you click on the tile, it actually turns itself over, and it gives you a range of options and a detailed view of where you are. Now, if I look at this image, I see a triangle in the middle, and that's the mean for the building right now. That's my average. And I can make adjustments to that in Insight. I can actually make changes to get different metrics. And so as the report is selected, the 3D model will update itself. And it goes into a mode that helps you explain what's going on with the building. So if I pick something like a PV option to see what area I have available, then it'll actually highlight those areas that are available. And I can change the options for the graphics here and use these as part of my presentation documents by simple cut and paste, copy and paste. Everybody knows how to do that, right? Oh, got a couple people don't. Okay. So when we move past this, we look at heat and cooling loads. Oh, I've screwed up my graphics. I'm sorry. Got a little box out there. The heating and cooling loads is a tool that's now built into Insight 360, and it's based on Energy Plus. And what it does is it takes data that's derived from the model space and zone data, objects, and anything else that's included in there, and it generates the report and gives you those options. So now it's not just some random tool. It's actually using Energy Plus to make this calculation. And again, once I get into the HVAC types here, I can start to adjust what systems I might want to use and get a better result. So when you edit the Insight, it's going to let you see what the energy cost mean is. And you can toggle this back and forth between cost mean and the annual cost of what it's going to cost. If you're trying to translate for a layman My mom, I love her to death. She's 82 years old. She's who I got my speaking skills from, so I'm going to apologize for Mom right now. She's great. She does a great job speaking. But the insight lets you see these values, and again, you can make those changes and adjustments. So you just pull the range in and out and show the change automatically in the mean. So it's a pretty cool little tool in there. It's just very simple to use, and it doesn't require a PhD to explain what's going on to somebody who has a common problem. And it helps improve the overall benchmark in the energy use intensity. So you see how we compress this and we move this value down, how our energy cost changes. Very simple tool to use. You also get summary reports that are generated for you. And these can be put into Word format, put into other documents, and they show you what the overall building summary is going to be, what the value of the components is going to be in terms of what their loads are and the percentage of total. And then you can break it down into individual spaces. I can look at an individual room and say, these are what these values are. Now again, do I actually have to leave Revit to generate this? No. It's all sitting up there on the internet. And as I make the changes to the model, I simply go back and regenerate another insight. So this is where 2017.1, and what I was waiting on for this class to see how they were going to do this, was how do they build these tools in. And the first thing they do is they changed where the set location was. They kind of rearranged the tools a little bit and said, let's have a tool that follows the steps that a user is supposed to do when they're doing an insight. So you start by defining the location, and after you do that, you create the energy model. So, okay, let it go ahead and do that little 3 or 4 or 5 or 10 minutes to create the energy model. After you do that, you generate insight, and all you're doing is running the reports up to Insight 360. It all does it in the background for you. There's no more export GBXML, check all the surfaces, do all this stuff. You don't have to do any of that. Once you generate the insight, you can always come back and edit the energy settings later for a more detailed result. But as you pick the Optimize tool, it goes back and updates the model, and it continues to give you model runs based on the same insights. How many model runs do you think you can generate with this tool? Every time you make a change, you can run another insight. And so it's very simple to make these changes. What's stopping us from taking a better look at what the building is doing here? So you're breaking down into 2 areas in here, analytical space and surface schedules here. This schedule is actually added to your Revit file. And so when you go back and look, it's showing you the area of each room and the volume of each room. And if you have multiple rooms that are the same type, you can actually do it by count, or you can break it down by individual instance. You have a breakdown of the analytical surfaces. And what's really cool about this that I like is that this is giving you the area of all of those surfaces that are defined to be a non-sliding door, an operable window, an exterior wall, an interior wall. It's actually breaking that information down for you, so you know that by changing those overall areas, it's going to change what my energy model does. We go past this and look a little bit more. We're going to look at a few more tools. We're actually running a little ahead of schedule, so this is really good. We get to ask some questions. There are 2 other tools that come with this now, lighting and solar analysis. Now, before anybody says this, and I'm guilty of doing this, I get excited when I see somebody say they have a lighting tool, because what am I thinking about? I'm thinking about lighting loads in a room. I'm thinking about lighting design, right? I'm thinking about how bright that room going to be. Boy, did I get educated. I had to go back and say, no, this doesn't have anything to do with lighting design. It has to do with lighting load. Something, again, that we never really took into account. And so what Insight does is it has this cloud-based optimization tool that allows you to fall into several areas in here. I can do a LEED compliance option 2. I can do LEED 2009. And I can do a custom level report in here. And so let me see if I can get this thing to work the way I want it here. I get my pointer to work. See if that works? Yeah. If you look right over here, you're going to see that you have the initial report that shows up that says, prepare the model. You want to make sure you have the location set. You want to define your surface and glazing materials. Make sure your rooms are defined, set your options, and then manage what your analysis cost is going to be. Because this is a cloud-based tool, you can actually use cloud credits for this. In some cases, they're required. In some cases, they're not. So that's what Autodesk is doing, is they're making this a cloud-based tool that you can use the cloud credits that you get with your subscription. It's one of the options that you have for it. And it really doesn't take a whole lot. I've actually done some that you see this one actually says that it's 0 credits. It doesn't require any, even though it's a high-resolution model. Just depends on the size of the building and how much stuff that you have in here. Once you get past the initial settings, you select the study settings that you're going to do, and you can use a predefined report that says these are your thresholds, these are your illuminance settings based on this particular threshold, and then you can run a check price to see how many credits you have available in here. You can also do a custom one, and this is the part that I like, is you can actually define the environments and override the environments here. So let's say that I'm doing a prototypical building. I could actually say, okay, this is a prototype for this one site, which we did a lot of maintenance buildings this past year for New Jersey. I could actually do an analysis based on that prototype, but simply move it to another location and say, this is going to be the impact of this location, this is going to be the impact of that location, this is going to be the impact of that location, with just changing one value. Not complicated. You can also say, what level am I working on? I'm working on the first floor, and then say, what do I want the thresholds to be? What am I looking for the analysis plane height? Now, I will tell you something about this. This is not in the book. Well, it might be in the book somewhere, but I talk about the analytical property of a room and a space. And when you go into a room or a space, there is already an analytical level defined. Have you ever got a room where you got a wall that's sloped like this, right? What happens if my analytical space is at like 2'6", but the wall's really bent out like this? I get a gap right here in my energy model. I'll give you a tip. Set your analysis plane and set your analysis plane to be as close to the widest area of your room. It may be on the floor, like an inch off the floor, or if the wall slopes this way, it might be an inch from the ceiling. But you want that to be there so you get the greatest area for the analysis. Better to have too much than not enough. Does that make sense? Because we're not doing straight buildings anymore. Nobody does. Curved, well, it doesn't matter what the wall is curved, angled, sloped. It really doesn't matter. You just have to know to go set where that analytical plane is. Okay? And that's actually, I think that is detailed in the handout, so just take a look at that. After you get done, you run your analysis. A schedule is going to be generated for you here, and this one was incomplete, but it'll actually tell you what your areas are, whether or not something's included in the daylighting result, whether or not you're going to include shades, and then what your 9 a.m. and 3 p.m. threshold results are. What percentage of lighting am I gaining from natural sources in here that can offset lighting inside the building? And are we hitting a heating and cooling load threshold that we might need to address with things like shading? Again, we're not talking about light levels in a room. We're talking about the impact of heat gain from a light and combining daylighting in a room. You get a lot of solar gain, especially down in the south. I practice passive solar cooling in my house. I close the blinds, right? Because I have to work upstairs and it's hot up there sometimes. So can I do more shading that way? Absolutely. The other option we have in here now is photovoltaic, and I tell you, as I look at all the different options that we have for energy, I'm really the most excited about this one because I think it has the most potential for us. It has a minimum impact on the environment, and it's something that can be localized to the point of where I put this into my house and I'm making an impact. If you asked me to do this 20 years ago, I probably would have said, no, I'm not going to do it because the systems weren't that efficient, the results weren't that efficient, and it really costs too much. How long is it going to take me to get that return on investment? And I learned the hard way about return on investment because when I built my house 17 years ago, I got my bill and I'm like, I can't afford an efficient HVAC system. And I live in the country, so I have LP propane gas. Love that stuff. Stinks like rotten eggs, right? And so we went ahead and didn't put a high efficiency system in there, and then that winter was a little rough, and I got my first LP gas bill, which isn't paid out over months. It's paid out when they fill that 500-gallon tank up at $3 a gallon. It had been as high as $4 a gallon. I'm getting $2,000 bills at once. So after 10 years of losing money and giving it to the LP gas company when I could have been out buying somebody a fishing pole and taking them fishing, I finally went and got a high-efficiency heat pump, a water source heat pump system put in, and just did the downstairs. Anybody want to take a guess on how much money I saved the first year? I cut that bill from, it was running annually about $3,500 a year, $300 a month. I cut it down to $1,800. You know, you think about this. If I had really sat down, if somebody had sat down with me 17 years ago and said, this much right now, this much later, it might have been a whole lot easier to bribe my mortgage loan officer wife into saying, hey, let's get a little bit more money. Of course, I'm married to a banker, and I live on a budget. I get an allowance, right? She's good with the money, man. She's like, no, we're not going to spend that right now. Well, we both realized that we should have made this decision earlier. How hard is it to help somebody make that decision now? So when we look at things like PV, what are we looking at? Are we looking at what, are we really looking at what the amount of electricity is that we're going to be getting this? No, not really. We're looking at the building and saying, what's the potential of the building? Are there surfaces in this building that work for us in such a way that we can maximize the PV potential and maybe reduce the number of panels that I need? Or change the location of something and maybe get a longer term return on where that energy is coming from. Now, I'm still kind of waiting to see. With me, I'm more interested in what's going to happen with the long-term effects of actually storing power, because did anybody hear about Hurricane Matthew that came through North Carolina and South Carolina not too long ago? People were talking about Florida and South Carolina, North Carolina's who got nailed. I had a foot of rain at my house. I missed the NC State Notre Dame football game that I had tickets for. Go Pack. And so it was really tough. I mean, before we were leaving to go to the game, we had 4 inches of rain, and we're sitting there looking, we're going to have some flooding problems. Really crazy. 3 o'clock, guess what happens? No power. Goes on Saturday. Goes on Sunday. Goes on Monday. My wife's family's from eastern North Carolina, down around Lumberton, Chadbourne, Whiteville, little towns. From North Carolina, you know where these places are. My oldest son is in law enforcement and spent a couple of days down in Lumberton, a week after the storm went by. There's water up to people's roofs. They're like the storm was a month ago or a week ago. We still have flooding. And it's amazing to see the impact of something like that. And we're sitting here looking at energy sources. How do we get this stuff restored quickly? I'm sitting here running a generator. But could I use something like solar as a way to disconnect from this grid and give people power the way they need it? And when you start looking in more rural areas now, especially in North Carolina, you're seeing a lot more solar power coming into place. Duke Energy has been putting up solar panels all over the place. Now, me personally, I don't want to give my money to the energy company. I got better things to spend my money on. Don't you? You got a kid? Take him fishing. Better places to spend your money. So when I look at potential like this, and I'm looking at a tool like this, it helps me understand how I can leverage this type of technology and do it pretty quickly. And so when I get into the model, I can generate a report here that says, okay, on this side of this building, this is an admin building for a water treatment plant, this side of the building is going to get the best gain right here. That's the best location that I can go and put solar panels on. And it gives me a report that says, look at the analysis. What's the annual energy value in this? What's the, at different loads, what's my daily analysis? What's my hourly? And I can change these reports simply by selecting a different type. And I can also change the colors and make them pretty, right? Again, well, who are we trying to help? Is it the PhD at the university? Mom. Right? If you can explain something to my mother and get her to understand it, you've done your job. That's who we need to convince. It's not us. It's our industry responsibility. It's our individual responsibility to say, this is what we need to do. And so once we take that narrative back and we change the narrative back to us as a design industry to take advantage of these tools, that's when the change is going to occur. Does that make sense? Okay, cool. So we're going to wrap this up a little bit early today. Questions? If you have a question, come up and stand at the mic here for me real quick, please. Come on up first. We'll go front row first. State your name and who you work for and how much money you got in the bank.
Andrew Lyons, Gresham Smith and Partners, Nashville. I was wondering, can you bring this information back into Revit?
Can you bring this information back into Revit? Yes, the information does come back into Revit. Absolutely. And if you notice the schedules that were generated in there, those schedules will be populated for you. Okay, so it's already filling that information out. Now, where's some of this information going to show up? It's going to show up in some form of a schedule. It'll show up with the properties of a space. It'll show up with the properties of a room, depending on what your analysis is. Does that make sense?
So you can show those values on the floor plan then?
Yes, you can show those values on the floor plan. Absolutely. Who's that? Who's next? Come on up here to the mic. State your name, where you work, and how many kids you have. Oh, you're a long ways from home.
Yeah. I have two babies, two girls.
Okay.
Just in case you want. Thank you.
Bring them to my house. We'll take them
Yeah.
fishing. Yeah.
Just regarding the solar analysis and the lighting analysis. I've tried this insight on a tower building, and I had to select the curtain walling one by one. Is there a way that you can select the
Yes,
whole thing?
he has brought up a point about curtain walls having an issue. I don't remember where the setting is, but what you want to do is you don't want to turn off the individual, you don't want the individual surfaces being what actually is used as part of the bounding element. I got to remember where this is. I'll have to look it up. But you don't want all the individual mullions to be bounding elements. You want the curtain wall to be recognized as one object. Okay. Yeah, you got to select each pane. Yeah, that's a known issue. Talk to me after the class. I'll try to give you a little bit of insight on that. Who else is next? Let's get some more up here. Come on up. State your name, the company you work for, and how much money you've lost in the casino so far.
I'm Ron Resvam, work for GSPS Architects at Salt Lake City, Utah.
You've got it written down. I'm in trouble.
My question is, I used to use energy analysis for Revit. I see that going away in the latest update. And that would give a very detailed report on energy use. I don't see that level of
You don't see that level of
accuracy
reporting?
in Insight. So I want to know if I model entirely with thermal properties, spend a lot of time to make sure all of my spaces and rooms are correct, materials have thermal properties assigned, and set Insight to use all that value. Can I count on this tool as something very reliable and be very close to actual reality as to the numbers it throws at me?
On the surface, I'm going to tell you yes. I mean, because some of the reports I've run, I would go back and compare it to another model that I might run in Trace or in Green Building Studio or take it into virtual environment. I mean, there's different means in here. By the way, this is not the only tool you have to use. This is just one option. There are going to be, you're right, they are limited on some of the reports that you can get. And so if you need a more detailed report, again, I'm trying to address the layman part of giving somebody something visual that they can show as part of the sales to help somebody close something. If you need a more detailed report, you might want to consider using something like BE. You might want to consider using Safari. I mean, there's different tools that have expanded reporting capabilities that this doesn't have yet.
Okay.
Okay, all right, so how about 18 months, 2 years? Give me a minute, man. I just got the wheel cranking here.
And my other question is about lighting analysis and how can so if I have a building surrounded by trees and other things, how can I make lighting analysis consider all those surrounding trees or masses?
Consider all the surrounding trees in the outside environment. It doesn't really do that, mainly because I don't think that the shading and the lighting is based on generalizations. It's not based on surrounding conditions. If I was doing a true solar analysis with surrounding buildings, I probably would do a conceptual model, not a detailed model. And I'd start off with a solar and shading design right inside of Revit first to see those impacts. If you do it with conceptual masses, it will pick up those items as an impact item. But if you got something like a tree, I don't think it's going to recognize that because vegetation is not one of the options for conceptual construction types.
Okay.
But as long as it's a mass, you can cheat, get away with it. If you really want to be sophisticated, make a tree a mass.
Okay.
Anybody know how to do that in Revit? You know how to convert a solid to a mass? Oh, come see me later. I can show you how to do that.
Okay, thank you.
That's a pretty cool little tool. All right, who else? One more here. We got about 5 minutes. So.
I was wondering, does LEED recognize Revit or Insight as an acceptable energy evaluation tool?
Does LEED accept Revit and Insight as an energy value tool? The reports that you saw for the lighting, those are accepted. Now again, keep in mind, guys, we're talking about a product that's less than 2 years old. There's going to be some time going through this. And LEED is not just about a report that you get out of a software program. It's about what's in the report and does it meet the criteria set aside by LEED. Okay? So if you need to add or alter data, it may be that you're using the image, but you're adding your own tables with additional data as needed. Okay? So it's like me. I don't depend on any one of these tools to do my report for me. If I'm doing a thorough analysis report, this is just a tool that I use. And I use it mainly for the presentation and for that part to be able to explain to somebody what's going on. And then do you ever sit down with a client and show them your Revit model? Who does it? Raise your hands real quick. Who actually sits down with a client with Revit open and does a presentation with a client and make changes in a meeting? If you're not doing this, get up off your tail and start doing it. Because again, it's the McDonald's theory of CAD. You're showing pictures to someone to help them understand. And that's the beauty of this stuff, is you can make these changes immediately and they can see that impact. So I could actually be sitting in with the client and say, hey, look, instead of we using this heating and air conditioning system, let's switch over to this type, and this is your cost. You're getting buy-in. You understand? This is about selling the client what the option is for the energy modeling for this building. Honestly, I think we do too much sometimes. And I know governments require that, but if I'm dealing with a private company like the Sands, big on energy, you know, having something like this to show a conceptual change to a building and getting buy-in very early on makes it a whole lot easier when you come down the road with your design. That's what you're using this for. All right, anybody else? We've got about 3 minutes. We're good? Okay, well, let's wrap it up here. What I'd really like for you guys to do, take a chance, go back and go through that handout. And then if you have questions about any of this stuff, man, find me. Email me, call me. You can find me on the Expert Elite forums. I'm out there on a regular basis. My email is published in about 8 million places, so you guys can find me. I have people that still email me, hey, we were in your class today, you. This didn't work. When you get out of here, we also want you to make sure you do an evaluation on these classes, because this helps us, Autodesk University as an entity, make judgments on what kind of classes people really want to see and how big of an impact they have. So remember, your class number here is MP 19638. If you've got the AU app on your phone, you can do the analysis there. And you can go ahead and fill in questions, make comments, do that other good stuff. I see all of it, so don't cuss at me. My mama might be looking at it too. But again, take the time to do this stuff, change the narrative, start using these tools. Thank you very much.